I told you that a buffer solution resists the change in pH, that the equilibrium is going to shift both ways in both directions. And it's going to resist, if you try to increase the concentration of H plus one ions, it's going to try and decrease it. It's going to do the opposite. And if you try to decrease the H plus one concentration, it's going to favor the forward reaction and try to increase it. Now, most equilibriums behave that way. But with buffers, the thing was that if you add a weak acid, the amount of ions that are going to be produced would be very less because it's a weak acid. So if you have 1,000 molecules of ethanoic acid, very few ethanoate ions and very few H plus one ions are going to be produced. So if you decrease the concentration of H plus one ions, the equilibrium would shift in the forward direction, but that's not going to be an issue. Why? Because you have thousands of molecules of ethanoic acid and they can dissociate. The issue was that if you try to increase the concentration of H plus one ions, the equilibrium should move in the backward direction, but it's not able to because if you add 50 H plus one ions, you need at least 50 ethanoate ions, and the amount of ethanoate ions that are produced by a weak acid are very, very few, which is why the backward reaction would be limited. Hence, you have to somehow increase the quantity of this ion so that you don't run out of these ions. So that when the equilibrium wants to go in the backward direction, it should be able to go in the backward direction. Even if you add 100 H plus ions, those 100 H plus ions, the equilibrium should shift backwards, and there should be enough ethanoate ions present that it's able to shift backward. Okay, so is that part clear?
Yes, sir.
So a buffer solution is formed not only by just adding a weak acid. I mean, you're going to get the equilibrium, but to have an effective buffer solution, you need to increase the quantity of the conjugate base as well, which in this case is the ethanoate ions. They need to be increased, and that they increase by adding a sodium salt or any soluble salt, not just a sodium salt. Uh, you increase that, and it forms a buffer. The expression, since the equilibrium is the same, your expression for dissociation constant K products over reactants only changes slightly. That previously we had stated that these two ions are present in the same concentration, but now you're artificially trying to increase the concentration of this particular ion. And because of that, the concentration of the two ions, H plus 1 and your ethanoate ions, they're not going to be equal. So this ion would be equal to the concentration of the salt multiplied by the H plus 1 concentration divided by the acid concentration. So you come up with this formula instead. So we're going to use these formulas to calculate the pH of buffer solutions. So I'm going to think of a few questions. We're going to try and solve those questions. For example, there is a question where now you just have to, I mean, initially the questions you just have to apply the formula. So for example, there's a buffer solution, and that buffer solution is formed when two things were added. So there's propanoic acid and the concentration of propanoic acid is 0.25 mole per dm cube. And you've decided to add the conjugate base as well. So the salt of propanoic acid is added, -1 Na plus 1, that is added, and whose concentration is 0.4 mole per dm cube. Now these are added, and the Ka for propanoic acid is already given. It's given as CH3, CH2, COOH. Its value is given as 5 into 10 to the minus 6 mole per decimeter cube. So this is given. You're just simply being asked to find the pH of the resulting buffer. What's the pH? So you can just simply apply the formula, which is That dissociation constant Ka is basically conjugate base concentration, the salt concentration, into H plus 1 concentration divided by the acid concentration. So you need to divide this by the acid concentrations. The values are all given above. The K value is given as 5 times 10 power minus 6. Can you take out your calculator and start doing the calculations?
Yes,
The
yes.
conjugate base concentration is 0.40 mole per decimeter cube. The acid concentration is given as 0.25, and H plus 1 concentration. So find H plus 1. You find H plus 1 and then take the negative log, you're going to get the pH.
The answer of H plus is it 3.125 times 10 to the power negative 6?
See, it's 3 point.
3.125 times 10 to the power negative 6. 3.13. Okay.
Okay, so it's 3.13 mole per dm cube.
It's correct?
Yes, I mean, I just
Yes.
made up, I don't have answers. I just made up this question. So if you did the work,
Okay.
it looks correct.
Okay. Now the pH, we need to do a negative log.
Yes.
Okay. 5.5.
So it's coming out to be 5.5.
5. Yes.
That's going to be your pH, right? So this
Yes.
is the entire question. Now, one issue that you're going to face is a lot of times it would be hard for you to understand. I mean, what you need to identify is because acids come in many shapes. Remember, uh, the most general shape is that this is how an acid would be represented. I mean, it breaks down into and produces two things. One is H plus one. The other thing is A minus one. Right. This is the acid. This is the conjugate base. Now, in these questions, I mean, for organic acids, I mean, you're familiar with carboxylic acids, or mainly you're familiar with carboxylic acids. So it's kind of
Yes.
easy for, as it's kind of easy to identify which one is the acid, which one is the base. The problem would come when you need to identify. I mean, basically, let me write the heading. Identify which one is the weak acid, which one is the conjugate base. ठीक है? So for example, अच्छा, so for example, आपके पास you have a solution, a mixture of it is 4Cl, and the concentration is given as 0.45 mole per dm cube, and you have another thing mixed with it, which is NH3, and the concentration is given as uh, 0.15 mole per dm cube. Now these two things are provided, and you're being told that they form a buffer solution. I mean, these two together, they are forming a buffer solution. And now the issue is which one is going to be acting as the acid, which one is going to be acting as the conjugate base. Uh, so always remember, uh, especially like you have to write the equation in this form. Always remember the thing that has more H plus one ions is the one that's going to be acting as the acid because it has more H plus one ions. So for example, over here you have NH4 plus 1. Now, NH4 plus 1 is definitely going to be acting as the acid because it's going to lose H plus 1 ions to form NH3. So the NH4 plus 1 ions would be the ones that would be acting as the weak acid, and the NH3 is the one that's going to be acting as the conjugate base. So this is exactly the same form of expression as the one that's given above. That HA, that's the weak acid, dissociates to produce H plus 1 and A minus 1 ions. So sometimes it could get tricky to figure out which one is the weak acid, which one is the conjugate base. But another way to figure this out is that most of the time the Ka would be provided for the Ka value would be is always for the weak acid. So they might have given you the Ka value, and that would have indicated that. Uh, so let's say it's 3 times 10 power minus 5 mole per dm cube. So based on that, you can even figure out which one out of the two is acting as the weak acid. Sir, is this clear?
Yes, sir.
ठीक है आयशा क्लियर है
जी सर
अच्छा अब इससे आगे के I mean we can write the expression conjugate base concentration divided by take out your calculator and find the everything is given find the value of the pH into H plus 1 concentration. So most of the things are provided. K value is given as 3 times 10 power minus 5. H plus 1 concentration is obviously not given. And you have NH4 plus 1 concentration. Conjugate base कौन सी है? It's going to be NH3 concentration, so it's going to be 0.15. And you're going to divide that by 0.45. Okay, so you have to be careful about using this formula. As I try and figure out what the pH is going to be. ऐसा किया आपने calculations?
0.01
अच्छा कितना है 0.01? नहीं. Well, the value would probably come out to be very, very small. Times 10 power minus 5 है. Okay, 3. Sarah, did you do this?
Yes. The H plus is it 9 times 10 to the power negative 5?
Okay, so H plus 1 is 9 times, yes.
9 times 10 to the power negative 5.
And what's pH? Aisha,
Negative log. Yes. Okay. Yes.
and what's the pH? Negative log.
Negative log times 10 times 9 times 10 to the power negative 5, which is 4.4, which is 4.04. No, 05.
4.04?
05.
Okay, so it's 4.05. So it's 4.05. So yeah, this is one type of question. Then you have questions where then you have questions where you might be asked to write equations. Okay, so you'll be asked to write equations for buffer. Okay, so for example, you're being asked that there's a there's a buffer that's formed when NaHSO4 and Na2SO4 are mixed together, right? These two are mixed together. The first thing would be obviously that you have to figure out which one is going to be acting as the acid and which one is going to be acting as the as the base, as the conjugate base. As remember, sodium ions or any soluble salt, it's going to dissociate in the solution. So it's basically a mixture of HSO4 minus 1 and SO4 minus 2. The sodium ions, as soon as you dissolve them, the sodium ions are going to break away and they're going to get mixed in the solution. So they're just spectator ions. They're not doing anything. So it's basically HSO4 minus 1 ions and SO4 minus 2 ions. And this would definitely be the acid. Why? Because it has more H plus 1 ions. So it's going to be HSO4 minus 1, which is going to be in equilibrium with H plus 1 and SO4 minus 2. Um, and you can be asked about this. What would happen if, I mean, this is the buffer that's going on. This is the equilibrium that's going on. If you try to increase H plus 1, the equilibrium would shift backwards to decrease it. If you try to decrease H plus 1, the equilibrium would shift forward and it would try to increase H plus 1 ions. So the equilibrium is trying to maintain the concentration of H plus 1 ions. So if H plus 1 increases, where should the equilibrium shift? That's the question. So if you try to increase H plus 1 ions and their concentration, the equilibrium is going to shift in the backward direction. The equilibrium is going to try, according to Lee-Shatler principle, it's going to try and do the opposite. It's going to try and decrease the concentration of H plus 1 ions. Uh, so you're going to write the equation that H plus 1 would react in the backward direction, SO4 minus 2, and it would start forming HSO4 minus 1 ions. So the extra H plus 1 that you've added, the SO4 minus 2 ions are going to take care of them, and they're going to get used up. So the concentration of H plus 1 is not going to increase. I mean, you're going to try and increase it, but it's the equilibrium would shift to counter that. So is this part clear?
Yes, sir.
So the other part is, what if you decrease H plus 1 concentration? That means if you decrease H plus 1 concentration, the equilibrium would try to make more H plus 1 ions. So the equilibrium would shift in the forward direction. Now, how do you decrease H plus 1 concentration? The way you can decrease H plus 1 concentration is by adding OH ions. The OH ions are going to neutralize the H plus 1 ions. Okay, that's the only way to remove H plus 1 in a solution. You add OH ions and the OH ions would react with the H plus 1 to form water. So H plus 1 would decrease if you add OH ions and the equilibrium would shift in the forward direction. So we're going to write the reaction in the forward direction, which is going to be K. There's going to be HSO4 minus 1. In the forward direction, it would form H plus 1 and SO4 minus 2. So this is what will happen. But you're adding OH ions, so you need to mention what the OH ions would do. What the OH ions would do is that the OH ions are going to come in and the weak acid would dissociate. It's going to produce these H plus 1 ions, and these H plus 1 ions are going to react with the OH ions to form water. So you have to alter the reaction a bit. Okay, so I'm going to repeat what I just said, that if you add OH ions, what happens in the equilibrium mixture is that the H plus 1 concentration decreases because the OH ions, they react with the H plus 1 ions to form water. And the equilibrium would shift in the forward direction. The HSO4 ions would start producing more H plus 1 ions because the OH ions are neutralizing them. So the equilibrium is going to counter that. It's going to try and increase, it's going to try and produce more H plus 1 ions. So you write the reaction in the forward direction, except for the fact that you need to add OH ions in the reaction. So you add OH ions, and what this HSO4 minus 1 would do is that it's going to produce the H plus 1 ions, and they're going to react with the OH ions to form water molecules. So this is the equation that you're going to write. Sarah, is this clear? Aisha, is this clear?
Yes, sir.
Acha, so the next type of thing, the next thing that's going to happen is so we're going to talk about some different types of questions. Okay, so for example, you have a question. Okay, slightly more difficult questions. So the question is that there is NaOH. There's 20 centimeter cube of let's say 0.1 mole per dm cube, NaOH is neutralized or is mixed with let's say 30 cm cube of 0.15 mole per dm cube, not NaOH, ethanoic acid. So there's a reaction going on, and 20 cm cube 0.1 mole per dm cube NaOH is mixed with 30 cm cube 0.15 mole per dm cube ethanoic acid. The dissociation constant of ethanoic acid is already provided. It's given as 2 times 10 to the power minus 6. So the dissociation constant of ethanoic acid is provided. Now, and you're being asked find the pH of the resulting solution. Now, the first thing that has to be done is that we need to somehow figure out what is this resulting solution. We need to figure out what's happening here. What is this resulting solution? So I need to first figure out what would be the reaction that's going to happen between NaOH and ethanoic acid. So we need to figure out what type of reaction happens. It's a base and an acid reaction. So that, I mean, there's nothing that difficult. It's CH3COOH, which is ethanoic acid. It's going to react with NaOH, and it's going to produce a salt. And a water molecule. So this is the reaction that's going to take place. Now the volume of ethanoic acid that's being used over here is given. It's given as 30 cm cube and 0.15 mole per dm cube. So can you try and find the moles? How many moles do you have? और इसी तरह the volume and the concentration of NaOH is also given. It's 20 cm cube. This is 0.1 mole per decimeter cube. तो moles के साथ निकालते हैं volume into concentration. So it's 30 times 0.15, and you need to divide that by 1000. So it's going to be 0.0045. तो इसके जो moles आ रहे हैं ना 0.0045 moles आ रहे हैं. Aisha, clear है? Sarah, is this clear?
Yes, sir. Here we use the number of moles in the concentration formula.
Yes, N is equal to C into V.
Yes. Okay.
ठीक है, so find the moles. I mean, what I need to do is, because I need to find the pH of the resulting solution. So I need to figure out what is the resulting solution. What do I have in the solution, right? So I mean, there's ethanoic acid being added and there's NaOH being added. And now I know that the two are going to react. So what I need to figure out is what do I have at the end of the day in the solution. So this is the first thing. It's 0.0045 moles of ethanoic acid. So we can find the moles of NaOH the same way. The moles of NaOH are going to come out to be going to be 20 into 0.1 divided by 1,000. So 20.1 multiplied by 0.1, and the whole thing gets divided by 1,000. It comes out to be 0.002 moles. And for simplicity, we can rub this off. So we have the moles. So this is what's happening. This is mixed with this. Now the thing is, according to the equation, they're reacting in 1:1. So that means 0.002 moles are going to react with only 0.002 moles, which means 0.0025 moles are in excess. I mean, you've added too much of them. TK, you just needed 0.002 moles of NaOH would react with only 0.002 moles of ethanoic acid according to the ratio 1:1. So 0.0025 moles is, I mean, that's more than the required amount. Okay, so out of 0.0045, only 0.002 moles are going to take part in the reaction. Okay, ये clear है? Sara, is this clear?
We subtract with the 0.002.
Yes, I mean it's. Do you know about limiting?
Yes, okay.
You know about limiting excess, like if I have, I mean, what I'm doing is that if I have 10 moles of this and if I have 8 moles of this, so how many moles are actually going to take part in the reaction? The equation is suggesting that they react in the same ratio, 1:1, right? So
Yes.
8 moles are going to react with not 10, but they're going to react with 8. So that means 2 moles are in excess. I mean, they're more than the required amount. So is this point clear?
Yes, sir.
Or we यहाँ पे कि it's I had 0.002 moles of this and 0.0045 moles of this. Now 0.002 moles are going to react, but they're going to react with 0.002 moles. So if you subtract that, so इसका मतलब 0.0025 moles जो है वो that they would be left at the end of the reaction. They're not going to be taking part in the reaction. They're not even required. ठीक है? So they're more than the required amount. आगे जाके produce क्या होगा? 0.002 moles of sodium ethanoate and 0.002 moles of water. ठीक है? और ये पीछे रह जाएगा, ठीक है? This is the amount that has not actually reacted. Clear है? So is this part clear?
Yes, sir.
अच्छा अब इससे आगे के so my mixture, ठीक है, the resulting solution. I need to figure out what the resulting so I need to figure out what the resulting solution is. So the resulting solution is water. So I'm going to ignore water, ठीक है? It's basically CH3 COO minus 1 Na plus 1 मतलब salt. कितने moles है? It's 0.002 2 moles plus the leftover ethanoic acid जो excess में था. That is still present in the solution. It hasn't reacted completely. So ये जो leftover ethanoic acid which is over here, it's 0.0025 moles. So that's my resulting solution. But it contains this product and it contains the leftover ethanoic acid. अब इन दोनों को अगर देखो तो that means कि they've actually formed a buffer. It's the conjugate base and the acid, the weak acid and the conjugate base. So that means जो resulting solution होगा ना, that's actually a buffer. ठीक है, ये clear है? आयशा clear है? Sara, is this clear?
Yes, sir.
Yes, sir.
So that means it's basically a buffer. और उसने कहा है pH निकालो इसका, तो pH के साथ निकलता है बफर का जो pH निकलता है, that is उसका फॉर्मूला क्या है? It's basically Ka conjugate base concentration यानी salt concentration into H+1 concentration, divide the whole thing by the acid concentration. और इसको मतलब ऊपर से ना वो K वैल्यू बीच में पुट कर देते हैं, तो K is 2 into 10 to the minus 6 और salt concentration क्या है? 0.002 moles. अच्छा, remember it's salt है ना, हाँ, 0.002 moles. It's not concentration, तो उसको आपको ना वॉल्यूम से डिवाइड करना पड़ेगा. But concentration निकालने के लिए moles have to be divided by volume into H+1 concentration divided by the acid concentration, which is 0.0025 moles, and they need to be divided by volume as well because you need concentration. Achha, but dividing by the volume is irrelevant because they are the same solution and they have the same volume. The upper bhi volume and niche bhi volume, and the two terms are going to get cancelled out. So you can, instead of using concentration of the base and the concentration of the acid, you can simply use moles. No need to actually do an extra step and calculate concentration because it's going to be pointless. क्योंकि वो volume वाली term जो है वो वैसे ही cancel out हो जाएगी because they're getting divided. ठीक है, try and find the pH now. I mean, try and find the H+1 and then find the pH of this solution. Aisha, Sarah, try and find the pH value.
Do I say the H plus?
Huh? Tell me what the H+1 value is.
2.5 times 10 to the power negative 6.
So H+1 concentration is 2.5 times 10 power
Negative 6.
ठीक है, just wait 2 minutes. अच्छा चले, Sarah, did you find the answer to the first one? Aisha, pH निकला पिछले
Yes, sir.
What's the pH of this previous question?
Yes, it's. Is it negative 2.5?
नहीं, why नहीं, it can't be negative 2.5.
Okay, I think there's something wrong. I'll check again. 5.6?
ठीक है, so it's 5.6. As anyways, you can, this question is similar. ठीक है, try and solve this question and send the answer to this one as well. ठीक है, I mean, there's a resulting buffer that's going to be formed, like the previous question, that NH3 is reacting with HCl. First, find what is the resulting solution. What does it contain? How many moles of each substance does it contain? I mean, there's a reaction of NH3 with HCl that's going on over here, and obviously NH4Cl would be formed. Then figure out what kind of buffer would be formed, and like in this case, even you had a reaction first, and then the resulting solution was actually a buffer. So this question is very similar to that as well. try and solve this question. Send me the answer on WhatsApp. ठीक है? Aisha, इसका आंसर मैं WhatsApp पे वेट कर रहा हूँ. ठीक है? Sarah, can you send the answer on WhatsApp?
Okay, sir.
चलिए ठीक है. तो okay then. Take care. Allah Hafiz.
Allah Hafiz.